Hello, my name is Mario. Welcome to another Learning Go video. In today's episode, I'm going to be sharing with you a pattern called functional options. As usual, the link to the code will be in the description of this video. It includes the final implementation. What I'm going to be showing you in this video is the actual step-by-step how I refactor a current implementation to support this pattern and why am I doing it in the first place. So let's look at this example that I have right here. Is your typical HTTP server implementation. You can take the same idea and do something similar with literally any type that you have in your domain, in your project. And to show you how it works, actually, to show you that it works, first of all, is that I can take and run it, and then I can do a curl x get http localhost 8080, and then it will print out hello. Nothing spectacular or crazy. So the idea with this is that when we have a type that we want to provide default values, the few different ways to do this is to extract this into a new constructor or initializer or something similar. If you remember, in Go there is no such thing as constructors, so the closest will be to literally instantiate the type using literally an instantiation similar to what I have right here, which doesn't have arguments and it's not specifically specifying the fields that are applicable to that type, or literally just passing in something like this. Now if I want to make, and this literally works, I mean, you can return this and I can use it right here, and literally that serves the same purposes, and basically talking in the context of the feature that I'm trying to implement is practically the same, right? So if I compile this, it will build. It says mux is undefined. Okay, so we're going to be moving this right here, and s equals mux. So I'll compile, everything is fine, everything is working, the thing, it didn't change, everything is fine and dandy. Now the whole point of this pattern is I want to provide default values or configuration values to what I have in the server currently. One way to think about this is that, hey, I have these three fields. I want to provide a way to configure those fields from outside of my function. Typically, the way we do it, we define three arguments. We define a time address, duration, read timeout, and another write timeout. And then we can change this to be other. We can change this to be read t, and we can change this to be write t. And then when we go around here, I can just literally do pass in the values that I had before, right? Everything pretty straightforward so far. Nothing really overly complicated. Now the issue with this is that the more arguments the more fields we need to be available for configuration, the more arguments we're going to be adding, and that could be problematic. The other problem with this is that when we are passing in fields that happen to be the same type, because the convention and the idiomatic way to implement functions in Go is to somehow or keep those types together to each other. For example, in this case, I have a read t and write t next to each other because I'm using the time duration type. Typically, this is the way you should be doing it, but you can argue with me and say, you know what, I want to move read t and make it the first argument, address the second one, and so on and so forth. However, it's not clear in here exactly what these values mean in the first place. It looks like a string, some sort of duration and some sort of other duration, but I don't know exactly what this means in the context of calling new server. Typically, what comes next will be to define another some sort of a struct that take these fields, and now we can pass it as an option, and we can call it server ops and make these fields exported. You can call it read timeout. Oops. And the same will be with the write timeout. So now you have this. We go and modify the code to match what we define above. So now instead of passing in a bunch of arguments, we change it in a way that it becomes what other programming languages, or when you are using an inheritance-based programming language, is called a DTO, or data transfer object. Typically a configuration kind of a class, which again in this case because Go doesn't have classes and doesn't have these kind of things, it works for sure. And you can define and call this address. Oh, it's called addr. Okay, leave it the way it is. I will rename it in a moment. We have read timeout, and then we have write timeout. And so far, everything seems to be working. It makes sense for what we're trying to do. However, this still don't solve what we were trying to implement in the first place, when we were trying to think, hey, now I already have values right here. We can make this explicit. Let me rename this to address. So now we have explicit values that need to be available when we instantiate a new server. What about those cases when we want to provide a default configuration? Defining a struct for those values does not solve the problem, because you will still need to perhaps maybe define a new server ops that indicates, hey, not that, but rather a new server ops that indicates, hey, the default values for this thing will be what I have down here, which is I'm going to use literally copy and paste everything right here, paste it, return it, and now you can define some default values, right? Just you can say new server ops, and now you have a function, an initializer of a type that is an options argument or a configuration argument that you can pass in to another type. That is overly complicated in my opinion. One way to solve this problem is to start introducing the concept of a functional option. And the way it works is by defining a new type called, that we can call it whatever we want, but in this case we're going to be called option, that receives, that is declared as a function that receives an HTTP server. And if you remember the video when I was covering and discussing about types in Go, you remember that you can define types like these that happen to be actual functions, and you can even add methods to those types. We're not going to be doing that, but this is one of those crazy things that is available in Go. It's really powerful though. So you can take that option, and then for each option, you can indicate and create functions that apply, that follow this signature, and at the same time make them as arguments, as default values of your type. Let me give you an example. So we have a function that says with address that receives an address type and returns a function. It returns the option, which in this case will be an HTTP server function. So we do this, and what we are going to be having is, because we are receiving that in the function that we are being executed as, we can actually assign the address right here. Let me rename this. And let's look at this before I add the other two values for read timeout and write timeout. So we have an option type that declares a function. So this right now, this option is actually a function. What is happening right here is that I'm returning the option, which is the signature that I have right here, is the same as this one. And the way we're going to be using it is by calling it right here. So let me remove all of this. We will not need any of these things. So we will do something like this with address s. So what is going to be happening here is that now I'm calling the option that I defined previously and passing in the address of the HTTP server. This is a bit hard to maybe comprehend in the beginning, but you will see how everything makes sense in a moment. If we continue with this, you will notice that I don't need this anymore. I will clean this up in a moment. Let me comment this out just for the sake of making sure that my editor doesn't go crazy. So I'm going to be defining three functions that implement the option type that will allow us to define arguments that we can use for the initializer that then we can use for configuration values. For example, we have one for function with address. We are going to be calling all with read timeout. That is going to be a time duration. And it's going to be doing something similar to what we had above, which is going to be returning the option. And let me copy and paste this to make it quicker. We have the read timeout equals to the t, and literally we're going to be doing something similar with the write timeout. So we have the write timeout t. Instead of using the read timeout field, we're going to use the write timeout field. And if we run this, it will compile, everything is fine, but really we haven't used that new code in the initializer that we define here. So what we're going to be adding is we're going to be adding a new argument to the constructor or initializer, and this is where the functional options comes in, and plus the default configuration values. I will show you that in a moment. We're going to be using something called variadic arguments, which is sort of a way to it's like a slice behind the scenes that happens to be one argument of any of your arguments. Usually I think it's only the last one, so it allows you to pass in values of the same type as arguments in the method. I will show you. It's a bit hard to explain, but yeah, I will show you that now all of this will make sense. So we have our server with configuration, and this is actually the opt right here is actually a slice, so we can do a range. And what I was showing you before is I can take opt, pass in the server, and as soon as I pass in the server, what is going to happen is, depending on the option that is implemented, the function that implements the option type will be called, and we will be receiving a pointer to the HTTP server, and therefore applying the configuration that I have right here. Okay, so if I go and modify this and I say, hey, with address, I don't know, 9191 with read timeout 100 times millisecond, with write timeout 100 times millisecond. Now let me move this to arrange this a little bit so you can see what's going on. Oops, it looks like, oh, I made a mistake. I'm missing, it shouldn't be in there. So like this, so I have this, I compile it, I run it, and if I try to run my example again, it will be running. Obviously, because now the port is different, this will give me an error. So I need to change it to the port I just added, so 9991, and now I'm explicitly indicating the values right here. The cool thing about this, instead of using, for example, a struct, is that you can define default values, default configuration options. Another good thing is that we can add validation to this. So if we go back and modify with option, and we say, you know what, we're going to be returning an error, and therefore we're going to be validating, oops, what the heck is going on? We're going to be validating the values that we are going to receive in the argument. Wow, what's going on with my editor? Sometimes I have this issue with Go Please, which is the thing that is powering all this autocomplete. It's just, I don't know what's going on. It goes crazy. My NeoVim goes crazy. So again, we are updating the signature of each one of the functions, and now everything is okay. Oops, I forgot one thing. That's why it keeps complaining. So I do error right here, and I do error right here. So everything now is following the signature that is defined in the option type. What comes next is to take this error, and if error is different than nil, then return HTTP server, and we can fix this typo, and we can do an error sprintf. We can wrap it because I don't know, option failed. We can wrap it, return the error, we can return nil. Obviously this has to be an initialized type, and here we change it to the signature now is different. So we are adding error all over the place to make sure that we are now honoring what we are supposed to be doing. Now we can change it here. If error is different than nil, we can say a typical, let me move this up, log fatal L, new server cooldown initialize server. I will fix that typo in a moment. So everything seems to be working. Oops, obviously this is incorrect, apologies. Cool thing that we have an editor that tells you more or less what's going on, right? More or less what's going on. So what's happening here is printf fail. Why is complaining? Let's see. So type is sorry, it's errorf. Obviously you cannot use printf for returning an error. You need to use errorf. So everything seems to be working. Everything seems to be fine. We don't have any validation yet, but let's say I want to indicate if t is greater than 1 second, I'm not allowing it to be greater than 1 second. So I want to return errors new, max timeout value not allowed. Let's call it, to keep it simple. So we can define this, and we can do something similar to the write timeout as well. We can say, hey, if we have a timeout, that is greater than 1 second, it's not correct in the context of what we're trying to do. Now, all of this works so far. I didn't really change anything except I added validation. But if you recall, the configuration that I have is still the same. The logic, let me open this in a different way. The values that I have here do not trigger the validation errors, or rather the validation itself, they don't return errors. But if I change this 100 millisecond to second, this will immediately fail because it's exceeding the validation that I have, because we are not allowing a timeout that is greater than 1 second. This is really powerful because not only you can have default values that I haven't added yet, but also you can add configuration options and validations to those configuration options. Now, about the default values, what I like doing is define constants. And the whole point of defining the constants is to make explicit the default values that I have. So I have read timeout time duration equals, let's see, 100 times time millisecond. We have a read timeout, which in this case will not be a read timeout, but will be a write timeout. And finally, we have, let's see, a server address. We can call it string equals 8080. Another thing that I want to explicitly indicate, we can call it default. So we have default values right here that say, hey, these are the default values for the configuration for our server and whatnot. And how this is implemented, when we are initializing the server, we can literally define this, which in this case, in the case of when the values are not passed in as part of the ops argument, they will not be overridden. For example, if I go back here and I comment out the line with address, what is going to happen is going to be using the configuration, the default value, which in this case will be 8080. So I change back the 1 second so it can compile and actually run. So right now 80, 90, 91 will be gone, and we're back to 8080. Really cool stuff, right? So I hope all of this you found it useful. I really like this way of defining default configuration options using this pattern, because it allows you, like I said, allows you to define validations as well as default configurations, and depending on the API that you have implemented, you can keep adding options without breaking the existing API. And with that, what I mean is that if I release this as a, let's say, as a package in Go, and if I want to add another with function, whatever users were using before, it will not break their compilation when they're using my package. I can still add new options without breaking whatever they have already existing. Well, that's it. Thank you for watching, and I hope you find this useful. Any comments, any questions, just let me know. Take care. See you.